Yeah, so just a precursor on next week's topic on probability. So let's have a quick look. We'll be looking at probability. It looks something to think about between now and then. A question. Sometimes it's good to stretch your mind and think of the implications and of where your thoughts might take you. What is the probability of you being you? Or what's the probability of finding another person who is identical to you? Each one of these little rungs here is a pair on your DNA, a base pair um, on your DNA ladder. And so we're separated by 6.4 million base pairs. This means the chance that two people are genetically identical is 1 divided by 2 to the power of 6.4 million. And it is incredibly close to 0. So let's just check it out and see what we can do. If I just tried to raise 1 over 2 to the power of 640, it just makes it. There is 193 or 192 zeros in the result. And that's just raising it 2 to the power of 640. Imagine if I raised it to the power of 640,000. Unfortunately, I can't go any bigger. The number it becomes too small. So 640,000 or 6.4 million. Imagine how small it is. If you tried, you could try it on Excel if you like, or your calculator, and you'll come up with an error, this little hashtag num error, suggesting that the number is too small for Excel to be able to display, or your calculator to display. Even 5 to the power of 500, it suggests wouldn't work. So this data here on the DNA and the 6.4 million pairs is coming from Science in Our World, Certainty and Controversy. And you might ask, yeah, but what about identical twins? Surely we're sharing the same DNA. And the thought is that, well, you're sharing a lot of similar DNA, but there is some stuff happening during your early development in the womb that there's some genetic changes still happening there. So you're not identical. Very close. But what's the takeaway point? I guess the takeaway point is that you're unique. And one last thing to think about, ancestral mathematics. In order for you to be born, you needed 2 parents, 4 grandparents, 8 great-grandparents, and it goes on and on and on. You've only got to go down a few generations and you're down to 2,048 ancestors there, 9th great-grandparents, feeding into your genetic makeup, your genetic pool, if you like. And for you to be born today, from 12 previous generations, you needed a total of 4,094 ancestors over the last 400 years. And that just made me think, what was their life like back in the 1600s, 1700s, 1800s, and 1900s? Here's a picture from Paris in the 1600s. What was it like? What would they think and feel if they managed to time travel to today and catch up with you and have a chat? Would you want to swap places with them? Would they want to swap places with you? Interesting thoughts where they take us. So look, next week, probability, lots of exciting things to discover together. So we look forward to catching up with you then.